Number 4. All right. A particle P moves in a straight line for 5 seconds. Its acceleration at time t is given by A equals 3t squared minus 4t plus 8 when time is between 0 and 5. So this is a question from the old syllabus, and on the old syllabus, you could use your calculator the entire test. So this is a no calculator portion up until 4C, and then for 4D, you're allowed to use your calculator. Okay. So write down the values of t when a equals 0. So the values of t when a equals 0, set the whole thing equal to 0. Right, all you would do here is factor this. Set each one equal to 0. You would get time equals 4 and time equals 2/3. 4b. Hence or otherwise, that means use the information from up top. Find all possible values of t for which the velocity of p is decreasing. So if they gave us a of t up here, and we want to find where the velocity is decreasing, what we're going to want to do is make ourselves a little sign chart. Okay? So this is going to be an upward facing parabola. We have roots at 2/3 and 4. Okay? And since these are the zeros, this part's going to be below the x-axis. This part's going to be positive. Okay? We're going to use this information in order to make decisions about the velocity, which is the integral of this guy. Okay? So if the derivative of him is positive, we know that the original function, or the velocity, is increasing. If the derivative, or the acceleration, is negative, we know that we have a decreasing velocity. And then if the derivative is positive, we know that we have an increasing original. So an increasing v of t. Okay, so they want us to find all possible values of t for which the velocity of p is decreasing. So we want this little sliver here. So we would say that t is an element of all reals such that t is between 2/3 and 4. That's when the, whoa, this is a wild thing. There we go. That's when the velocity is decreasing. Okay. 4C. When t equals 0, the velocity of p is 3 meters per second. So we have something that looks like this. And we want to find an expression for the velocity of p at time t. So we are given acceleration, and we would like to find the velocity function. Remember, for SVA, we are given acceleration. We need to work backwards to find the velocity function, so we're going to need to integrate. So let's go ahead and integrate that acceleration in order to find the velocity function. So we would get v of t is equal to t cubed minus 7t squared plus 8t plus c. Don't forget that plus c. They gave us this piece of information so that way we could find out what c is. So v of 0 is supposed to be equal to 3. So if I set this whole thing equal to 3, and then this is 0. Sorry, that's a minus. I will get that c is equal to 3. So the expression for velocity in summation would be t cubed minus 7t squared plus 8t plus 3. That will be my expression. All right, 4D. Find the total distance traveled by p when its velocity is increasing. So when its velocity is increasing, this is giving me my bounds, right? This is like find the spot where the graph of the velocity is increasing, and we're going to find the total distance traveled in those areas. Okay, total distance traveled, of course, is going to be an integral, and it's going to be the absolute value of v of t over that specific bound. Okay, so let's talk about when the velocity is increasing. The velocity is increasing from 0 to 2/3. Okay, and then the velocity is increasing again from 4 to, when is the interval over? Oh, 5. Okay. Okay. All right, so we're going to need to graph this velocity in order to like get an idea of what this graph looks like, okay? So let's go ahead and look here. Here I've graphed the red part is the velocity and the blue part is the acceleration. Okay, so the velocity is increasing from 0 to 2/3, and then it's increasing again from 4 to 5. 0 to 2/3 is above the x-axis, so we're all good there. 4 to 5 is below the x-axis, so to account for that, we are going to subtract the negative area. Okay. Notice how I've dropped the absolute value bars now that I'm thinking about it this way, where I'm going to be subtracting the negative area. So it just makes it way easier to calculate by hand. If we're calculating this by hand, we now have our velocity function as t cubed minus 7t squared plus 8t plus 3. And then this is why I was like, okay, this is a question from another syllabus. So like I thought it was a really great question to kind of put everything together, but it's weird because, you know, obviously finding the integral of something like this by hand is going to be a nightmare. So you can kind of type this stuff into your calculator and find it out. Also, you had to use your calculator in order to take a look at the graph and see what we were doing here. So if you want to do this by hand, go ahead and feel free to do it by hand. You would be getting something that looks like this. Okay, and your final answer would be 14.219. 3 sig figs would give you 14.2 meters as the total distance traveled when the velocity is increased.